Well, Assalamu alaikum dear students. I'm Engineer Abdul Basit, and as we have started that hydraulic subject, so today we are going to discuss that second week lecture, which is week 2, lecture 2, and the topic that we are going to cover is basic terminologies of hydraulics. So before going further in the lecture, let me talk about this terminology term actually. What does it mean by terminologies? Okay, for example, if someone is watching a cricket match and he don't know what is a pull shot, what is edge, what is LBW, or what is no ball, what is wide ball, so it will be difficult for him to enjoy that cricket commentary and that cricket match actually. Okay, because he does not know about the basic terminologies of cricket language. Okay, so for to understand the hydraulic subject, one must know what are the basic terminologies of hydraulics that will be particularly, or you can say repeatedly used in this subject discussion. Okay, like cricket. Okay, in cricket these terminologies like edge, LBW, that no ball, that wide ball, that bouncer, that yorker, these things will be repeatedly used. Okay, so these terms must be understand before going further in the subject. Okay, so let me move on. This is like, for example, density is one of them, as we have discussed few terminologies in the previous tutorial as well. Okay, you can go there to that video for further discussion. Next we have the density. Okay, density is a type of concept that can be used both in fluid mechanics, in soil mechanics, and in other subjects as well. Okay, this is something very common to us, for to engineering students and to FAC students as well. Okay, density is actually simply you can say that mass per unit volume is called density. Okay, or in other word you can say that mass in 1 unit volume is actually called that density. Okay, that is also the mathematical form, which you can say rho is equal to m divided by v. So this rho is a term that is used to denote the density, and this m is the mass of that substance for which you are going to determine the density, and volume can be any unit volume. Okay, so if you are using SI unit, so this mass will be in kg and this volume will be in meter cube. Okay, but if you are using English system, then this m will be in pounds, and this will be in inches cube or in feet cube. Okay, so these units can be used accordingly. Okay, so this rho is actually a lower case Greek word that is pronounced as rho, rho, rho. Okay, and another Latin word d can also be used to denote that density for you. But one basic concept, mistake that people make, especially in America, that state oil and gas industry, that they consider that unit weight and density is the same, which is scientifically incorrect. Okay, because density and unit weight can sound as both the same thing, but scientifically it is incorrect, because density uses that mass per unit volume concept, and unit weight is somehow different, which is using that weight per unit volume concept. Okay, if somebody is saying that this substance is having greater density and this is having greater unit weight, so both the sentences are having the same meaning, that this is a dense or densely compact material. Okay, molecules are closely spaced. Okay, but if somebody is saying that the density of this substance is equal to unit weight of this substance, so this is incorrect. These terms are having different units and different way of determination. Okay, and different formula for that, so that's why it is this sentence may be incorrect, but the basic concept or the basic pointing toward a situation or toward a concept is the same. Okay, so I hope this is clear to you. The unit that is used is kg per meter cube. Okay, kg is for mass, meter cube, this is m superscript 3. Okay, so this is density at 4 degrees centigrade, is density of water particularly is 999.9720 kg per meter cube. Okay, which can be taken as 1000 kg per meter cube in common. Okay, because there is no much difference between 1000 and 999.97. Okay, so you can use either of these units. 1000 will be easy to use and will be easy to remember, so I recommend to use that. Furthermore, in the discussion you can say how that unit volume will be considered and how it will be determined. So from this example it is quite clear. For example, we are having a cube and it is having a unit length, unit width and unit height. Okay, all these three dimensions of this volume of this cube is the same, and that is 1 meter, 1 meter and 1 meter. So if you want to determine the volume, so the simple way to do is to do this thing is, for example, this is V will be equal to volume is actually length multiplied by that breadth multiplied by that height. Okay, so here this is, for example, the length. Okay, and this is actually the width. Okay, and this is actually the length. So this volume will be equal to 1 multiplied by 1 multiplied by 1. Okay, and that will be equal to 1 meter cube. Okay, this will be actually 1 meter cube. So you can say that 1 meter cube is the volume of this cube. And moving further, if this cube is filled with water or some liquid, okay, so what will be the weight, what will be the mass of that substance that can fill this cube? Okay, that fill this cube. Okay, for example, it is water, so the weight of the mass of this water that is filling this cube will be equal to the density of water. If this is oil and oil is filling this cube, so the mass of the oil that fill this cube will be equal to that density of the oil. Okay, if it is something else, some other substance, this will be the same. So you can say this unit volume is filled by any substance, and the mass of that substance will be equal to that density. So this actually means that unit volume. Okay, in other words, you can say that for example, a substance is having condition like this in the cube, it is densely packed. Okay, and in this whole cube comparatively more amount of the molecules are accommodated, so you can say this is densely packed, so this is having a higher density or greater density, or it is a dense material. But if it is a loosely packed material, the molecules are far away from each other, there are a lot of empty void spaces. Okay, so then you can say this is loosely packed material and is having less density. Okay, specific weight. So specific weight is particularly there is a small difference between that density concept and specific weight concept. So you can say this is this can also be termed as unit weight. This here it is written. Okay, this can be written as specific weight, and in other words sometimes it is called weight density. Okay, and this density is actually called mass density sometime. Okay, so this should be kept in mind. Then talking about this thing, that specific weight or unit weight is actually denoted by this gamma. Okay, which is actually equal to the weight per unit volume. Okay, this is equal to weight per unit volume, okay, of any substance. In other words, you can say that this unit weight can be equal to rho into g. which is density into gravitational acceleration. So this concept is basically taken from that second law of Newton's second law of motion, which is equal to F is equal to ma. Okay, this is mass, this is acceleration. So if you are taking this concept for weight, this will be weight into weight is equal to mg. This is the situation. Okay, so if you divide both sides of the equation by v, by volume, so what is this? This is actually the density. Okay, this is density, and this thing is actually equal to now the this thing, which is the gamma. Okay, unit weight. So this is how this equation can be adjusted. You can say this weight is having a unit newtons or pounds. Okay, so you can say that this unit weight will have a unit that is kilonewton per meter cube, or sometime it will be pounds foot per foot cube. Okay, and there is a huge difference. You can see that the unit weight of water is actually equal to 62.43 pounds per foot cube. Okay, and that density was actually equal to density of water, that was actually equal to 1000. If you do remember this, we have discussed this in a previous slide, that it is kg per meter cube as well. Okay, so this is the difference between the units and also the term. So this was the thing I was actually mentioning to, that the value of the unit weight of water and density of water cannot be the same, as density is 1000 and unit weight is 62, but both are having the same concept. Both are showing the compaction, or you can say the spacing of the material. And in kilonewton per meter cube, you can say this is 9.81, and all these units are at 4 degrees centigrade, which is the standard temperature. Okay, coming to that concept again, so again we will have this volume, this cube for the volume, which is 1 meter, 1 meter, 1 meter. So multiplying all these three, this will be 1 meter cube. Okay, and if some liquid is filling this whole cube, so then the weight of that cube will be equal to the specific weight, because this is unit volume. Okay, and again instead of this density, this specific weight should be written over here, but the concept is same. Okay, this is loosely packed, this is densely packed. So it is having greater density, it is having less density, and it is having greater specific weight, it is having less specific weight. So both are same thing, density and specific weight, but as I mentioned, the units are different. Okay, and another thing, that basic unit for measurement of liquid is liters. So 1 meter cube is equal to 1000 liter. This should be kept in mind as well. Coming to specific volume. Okay, specific volume is simply the reciprocal of the density term, which is mass per unit volume previously. So if we replace that numerator of the density with denominator and denominator with numerator, so this will be actually reciprocal to the density, which is volume per unit mass instead of mass per unit volume. Okay, and then it is called specific volume. Okay, so in other words, you can say that if this is the cube, so here the weight of the fluid that filled this cube is actually specific weight. Okay, but for specific volume, you must say that the number of the cubes that are filled by 1 kg or 1 unit of the liquid, that is actually called specific volume. Okay, so here not the number or the weight, okay, is counted. Here the volume is counted. Okay, so the concept is opposite to each other. Coming to specific gravity. Okay, specific gravity is actually the ratio of the density of water to density of liquid to density of water. So if we are talking about any type of oil, okay, then it will be density of liquid, that is oil, okay, divided by density of water. Okay, if it is specific gravity of petrol, then this will be specific gravity of petrol will be equal to density of petrol divided by density of water. So simple, you can say specific gravity of any substance is actually the comparison of that substance, the comparison of the density of that substance to the density of water. Okay, so if that substance is mercury, so then you can say specific gravity of mercury is actually equal to the density of mercury divided by density of water. So this density of water will remain constant in every equation for specific gravity. Okay, all the substances will be compared with water only. Okay, so you can say as both the unit the quantities are the same in nominator, that is, and denominator. Okay, both are densities, so density and density will cancel to each other, so it will have no unit, so it is a unitless quantity, and same it is a dimensionless quantity. Okay, and specific gravity of water is actually 1. Why? Because density of water divided by density of water will be equal to 1. Okay, both will get cancelled to each other. Okay, if you are talking about mercury, so the specific gravity of mercury is 13.6, because density of water is much of mercury is much greater than that of water. Okay, now in other words, you can say that if some substance or some liquid is having specific gravity less than that of specific gravity of water, or you can say specific gravity less than 1. Okay, so it will float over water, it will float on the surface of water. But if it is same to that of specific gravity of water, or that is 1, so if the specific gravity of this substance and water is the same, okay, then it will be sank in the water, and it will be its top surface will be level to the surface of water. Okay, so you can say completely it will be submerged, but no water will be over the surface of this substance. Coming to their specific gravity is greater than 1 concept, if any substance or any liquid is having specific gravity greater than water, so that substance will sink in water. Okay, this will sink in water, so there will be some water above that substance as well. Okay, so this 1 is actually why this comparison is with 1, because 1 is the specific gravity of water. So you can say all these substances are compared with water. Okay, so if it is having specific gravity less than water, it will float on the surface of water. If it is equal to water, so it will be sank and top surface will be level to the surface of water. And if it is greater than, specific gravity is greater than water, so it will be completely sank in water. Okay, the same is the concept with wood is having specific gravity less than water. Ice is having specific gravity equal to water, and iron is having specific gravity greater than water. So this will be the situation to all of these substances. Okay, and that's all about this subject, this topic. Inshallah, in next tutorial we'll talk about the viscosity and Newton's law of viscosity. Okay, so I hope this helped you, and this will give you some knowledge about the basic concepts. Okay, later on this subject we will come will move towards few details as well. Okay, till now, thanks for watching video. Assalamu alaikum.